What's up, everybody? Welcome to Flux Harmonic. I'm David Wilson, and we're back again today with another instance of a live stream where we get together and try to code up something cool from scratch. Today it won't be so much from scratch because we're going to be extending something we already made, but it'll be fun nonetheless. So today we're going to be working on a preparation for the Ludum Dare 50 game competition. So we'll talk a little bit more about what that means in a minute. But what we're going to do is try to add some useful features to the Substratic library in preparation for the competition, which is this weekend. So starting April 1st on Friday, we're going to have basically a game competition that I'm going to try to participate in. And today we're going to try to finish some things up so that we have the features we need to do the competition. First of all, I'd like to say hello to Luis and to Robert. Thanks a lot for being here. Luis says, are you going to play the game today? No, we won't be playing the game today. Hey, Mark. Because I'll tell you that too, but we won't be playing the game today, unfortunately, but we will be adding stuff to it. So I did not have much time since the last stream to actually make improvements to the compiler, the game library, all that stuff, mainly because I was out on vacation for the whole weekend, like a 4-day weekend. I intended to get a lot of coding done. I actually did not get a lot of coding done, but that was good because it gave me time to take a break and think through some things and sort of refresh myself before coming back this week. So I have a lot more energy and enthusiasm to do the streams, which is great. So during that time, I've had a lot of ideas going through my head, especially around what I'm doing on YouTube with this channel and with System Crafters, and I've had some thoughts on how to improve this channel. I'm not going to go into detail about that right now, but maybe in the next few weeks we'll start to see some actual recorded videos show up on the channel, and it may turn out that I would do one recorded video per week and one stream per week. We'll see how that goes, but I kind of want to try something new that will give you the same kind of experience where we're building up something from scratch, but you don't have to watch me sort of scratching my head for like an hour and a half on streams just to get to something basic working. So we're going to see about that a little bit later, but at least for now, I'm thinking about this kind of thing. So if you ever have thoughts on how you would like to see a sort of more condensed presentation of what we do here on these streams, then please feel free to let me know in the comments, etc. Hi, Daigo. All right, so what we're going to do today, like I said before, is polish a few things before the Ludum Dare competition. So I'm going to be participating in the 48-hour compo event, which is basically a one-person builds a game from scratch in 48 hours and then submits it to be judged. And then they do pick winners in like 3 weeks because the community for Ludum Dare is going to basically rate all the various games and basically say who is the winner on various different dimensions like graphics, sound, gameplay, humor, some others, various things like that. Robert, hello, Robert. Thank you for being here. He asks, is this your first LD? No, it's not my first. I've done it one time before successfully, and then another time where I didn't make a whole lot of progress. So this would be technically my third time trying to do Ludum Dare. So I'll talk specifically about how I want to approach the competition in the next stream. So I won't go too much in detail about that today, but I will talk about my thoughts for that in the next stream for sure. So check that out on Thursday. But I thought it might be interesting to take a look at the rules for the competition in case you've never really done Ludum Dare before, Ludum Dare, whatever. And you'll get a sense for how this is supposed to work. So it says Ludum Dare is an event where you create a game from scratch in a weekend based on a theme. Themes are suggested and chosen by community. Theme suggestions are accepted starting 5 weeks before the event. Theme voting kicks off 2 weeks before the event, which has basically been going on right now. And then the theme is revealed at the start of the event. So nobody knows what the actual theme for the game will be, or for all the games will be, until the actual event starts on Friday, which is a couple days from now. So that's kind of cool because you can think a little bit about what you might want to do, but you won't know exactly what your real design will be until that day, and it gives you the ability to sort of be creative and think fresh on the first day of the event. All right, so there's a few different ways you could do this. One is the jam, which is meant for everyone, teams, individuals, anybody who wants to come and make a game. You can work alone or on a team, and you create a game within 72 hours. You're free to use any tools or libraries, free to start with any code base you may have. So I guess if you have an existing game, you can start with that. So you can use third-party art, music, audio assets, etc., but you can't be voted for in these categories if you're using somebody else's work for that. But if you want to use someone else's stuff as a starting point, you can do that. Also, they strongly recommend you only use assets that you have the legal right to use, which is pretty obvious. I mean, if you know anything about licensing or copyright, then yeah, you shouldn't be using stuff that doesn't belong to you. And then non-video game entry is not really important. The compo is one I was talking about before. They call this hard mode because you create something entirely from scratch by one person in just 48 hours. It's the ultimate test of your game creation skills. Well, at least in my case, I don't think we're going to see anything too extravagant. It's just going to be something simple. But the idea is just to sort of get you thinking creatively and moving quickly to make something happen in 48 hours. You must work alone. Your game, all your content, art, music, sound, etc. must be created in 48 hours. Source code must be included. You're free to use any tools or libraries to create your game. You're free to start with any code base you may have. So maybe that means you can start with an existing game if you wanted to, but it sounds like you're supposed to do it from scratch. And at the end, you will be required to share your source code, which is fine because, you know, that's what we do here. Compo games are typically reviewed harsher than jam games. If your game closely resembles a sample game that comes with a development tool, it probably won't get a good score. I don't really care about the voting. I mean, I'm not doing this to win the competition. I'm just doing it to participate, mainly because it's a good way to start a new project and have a very scoped time frame to work on it. So this is why I kind of want to do the 48-hour thing. Let's see. Source code is the stuff that makes your game a game. If you're using a development tool without code, we see it as your source code. Everything required to make the source work should be available publicly. If third-party libraries and tools are required, that's fine. If you're using an internal library to participate in the compo, you will be required to share it, which makes sense. I mean, the idea here is that not only are you building something from scratch, but you're also supposed to be sharing with the community. If you're unable to share your code, we suggest you participate in the jam instead. Jam would be a solution for me because I don't have, you know, a full 48 hours. I'm going to have probably half that amount of time or less. But, you know, we're going to make do with it because I want to try it this time. Blah, 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 blah. Derivative works. Yeah. Programmer art is welcome and encouraged. Yes, we're going to see some nasty programmer art. I'm going to try my best to do something. But I am not an artist. So does it say what the actual start time is? That's the only thing I don't know. Okay, the factors that they get rated on are innovation, fun, theme, graphics, audio, humor, mood, and overall. And then special category coolness. Okay, fine. Did they count coolness by using your own programming language to write the game? I don't know. Beware, we monitor suspicious behavior. We will not disqualify you, but any advantage you think you may be getting, we can take away in just a few clicks. I don't know what exactly people are doing to game the system here. And you don't have to use a theme, apparently, but I'm going to do it because why not? I mean, that's sort of the point. All right, so that's pretty much it for the rules. Okay, so Ludum Dare starts 3 days, 10 hours, 41 minutes. Okay, 4 a.m. EEST. So oh, okay, that's not too bad because I basically wake up at 5. So that's going to work out just fine for me. I think I'll start first thing in the morning and get going. Cool. All right, so let's get back to what we're going to work on today. So there's a few things that I want to add to the Substratic library, which is basically the graphics and game library that we've been writing so far in the mesh language for the Crash the Stack project. And there's a couple things that I want to do because I think they will be useful for the purpose of the competition. One is aligned text rendering. So right now you can render text using TrueType fonts with the renderer, but there's not a way to center text or to write aligned text. And it's going to be pretty easy, I think, to do the calculation to figure out how wide a particular string would be rendered with a specific font. So we're just going to write the code to do that. So then we can draw the text aligned to a specific point. So centering of text would be nice for like a title screen or maybe like a documentation screen or something. And then right aligned text we're going to use for the next thing, which is displaying an FPS counter. Basically, how fast is the engine actually running? What are the frames per second that we're getting? Ideally, I would like to hit 60 frames per second if possible. I don't know how the engine is going to tolerate that. I think the language is going to tolerate that. I think it'll be fine though. The language seems to be fairly fast at the moment, so we'll see pretty fast how that's going to go. Also, I would like to try to add automatic screen scale calculation, which is basically to render a retro-looking game screen to a more modern screen resolution or window resolution. So what we're going to try to do is target a low resolution, like 640 by 360. So you probably are used to hearing the resolution 640 by 480, which is a what's the aspect ratio for that? 3:2. Anyway, that's the square aspect ratio that old CRTs used to have. So 640 by 360 is 16 by 9, so it sort of fits the more widescreen monitors that people have these days. So that's going to be our logical resolution, and we want to scale that up to the real window size based on what resolution the person is using. So if they full screen the app, then we should be able to scale up the game in a way that looks right and has that pixely retro look on the screen, but also respects the aspect ratio correctly, also centers the screen a little bit if the actual screen size or resolution of the window doesn't match up cleanly with the target resolution. So we'll try to do a little bit of that. I don't know how far we'll get with it, but we're going to try to do a little math to make that work. So it doesn't sound like much, but you know, we've got an hour and a half, so I think that we'll probably fill the time trying to make all that work. And here's basically the list of tasks, which is effectively what I just said before. We will have to write a function for calculating the FPS and then maybe even lock the frame rate. I'm not sure exactly whether we'll do that or not, but I want to at least see what the frame rate is first. I do think that the way that GLFW works when it flips the OpenGL context, it is sort of locking the frame rate already, so we probably don't have to do that. But we'll at least be calculating the FPS. And I need to go look that up again, so we'll do that in a moment. Yep, that's basically it. So let's go ahead and just jump right into it. I think all my code is up to date since the last stream. I haven't really changed anything here, so let's go back to the compilation buffer and just make sure everything runs. Okay, that's mesh. Let's try running from here. Compile. Build.sh. Yeah, let's just use the old build script for now. I don't want to complicate things too much. Great. Last thing I want to do is download muzzle again. All right, let's not do that. Kill it. All right, let's do this instead. We're going to go back to the previous thing we had before. Where was it? Did I have one where I actually ran it after the fact? Let's see. Bin release mesh. No, that's not it. Not that one either. Apparently, I had not held on to the line for that. So let's try to pull it myself. I'm going to do... We'll delete this part. Manifest.scm. And then we'll pull tools/mesh build dist build main config dev. Let's just go with that and see if that's going to work. And then bin/dev/crash-the-stack. We'll see if this works. All right, good. Now, why is it spitting out all this information? Maybe I left a display in there. Let's find out. Main.msc, display, array length tiles. Let's see right there, display row. Okay, I already had some code in progress here, it seems. But let's take that out for now. We're not really worried about building the playable tile list. We were going to work on that, but I think we're going to focus on just getting everything ready this time. So build tile lists. Let's just not run that. Let's try it one more time. We'll take the display out too. Cool. All right. So now we're back where we need to be. Luis says, I think your own language should really be judged as coolest ever. Well, yeah, I mean, it should be cool, but we'll see if anybody actually picks up on that. There's a way that you can write updates about your game in the Ludum Dare website to sort of give context to other people who might be looking at it or reviewing it. So we'll give that a shot too, to see if we can at least explain what's going on with the game. Okay. So let's get to it. What we're going to do first is the font calculation. So I'm going to go into the Substratic library code in depths, Substratic engine, source. Okay, so I think I never actually brought the font code over from the Flux Compose code base. So that's what we're going to do right now because I forgot we had to do that. So we're going to go into Flux Compose, source. Was it? No, it's lib. I really need to go clean up that code base because there's a lot of stuff in there that doesn't belong anymore. Then we're going to go into, let's see, Substratic. Do we still have that folder? Yeah, good. And then engine, source, font.c. Great. Good old issue with some function I wrote for Vertigo. Grab this one more time. Now we're going to paste that in. Okay, so let me just see what mess I've got here. Is there anything flux on it? Flux internal, flux.h. So we have texture. I'm going to need texture.h. Interesting that this is here. I guess that's probably needed. So texture.h, and I would guess graphics.h as well. Okay. Probably need a font.h too for any of the stuff that we need to call into. So flux.h font. All right, let's copy this whole section here. So then we'll go into font.h here. And then I'll go into graphics. Oh. Do I have it in an include folder? Is that what happened? Include. No. Where am I? That was the wrong path. Let's go into substratic.h engine / source / font.h. Here we go. This is the right place. And then we're going to go into graphics. Come on now. Graphics. Where is it? Renderer.h. That's my mistake. Okay. I don't even remember what I named my own files, apparently. Okay, so this will be font. And then we're going to put an ndef at the bottom. And then we're going to change a lot of the stuff that we have in here. So Flux font is going to be subst font, since we don't have a better name for that right now. What do we call the render context? If I go to renderer.h, I have a... That just did subst renderer. Okay, so I'll change that. So Flux render context is now subst renderer. And then any flux underscore be subst underscore. So I think that's probably good. I also need to include mesh.h. For whatever reason, when I type with this keyboard, I type Y instead of U. I don't know why things are shifted over. Probably also need to pull in, include, like I said, renderer.h, and then texture.h here. I would guess I have a texture somewhere. No, I don't. Okay. Maybe in the other file. That's fine. Okay, so mesh memory. Yeah, the mesh.h should take care of all that. So now let's go back into font.c right here and do the same thing. First of all, I'll change this to renderer. And then I'm going to go back and run some of these same renames. Okay. Same thing for... Come on now. The other renames we've done, like this one. And then... What was the other? Flux font, subst font. Yep, that one too. We can try to build this in a second. The indiff in the font.h is misspelled. Thank you, Luis. Font.h, indiff, infi. Yes, indif. Who knows how I managed to do that? All right, so now I'll try to build it, but first I need to go into the project.msc. Yes. And then add this into the list of files to be built. So in here, we'll say font.c. Also, let's go into the build. Oh, did I already delete the build? Okay, cool. Font.o, no such file or directory. Interesting. Why did that not happen? Got a bunch of garbage there. Okay, no such file or directory ft2 build. I need to add the extra information about the free type library. So let me go back into the Flux Compose font code. I need to go into, was it the CMake lists? Will be in the upper level CMake lists, free type. Okay, so probably I need to use package config for this also. If I go into vterm, do I have package config libs free type? Free type 2? Okay. So maybe that's it. Let's get the C flags also. That seems right. Okay, so now we'll go into project.msc, and then we'll also use flags for, let's see, C flags, GLFW flags. Let's just add package config. Probably need a string append here. And then a space. And then package config free type 2 exclude libs t. All right, let's just try that now. Also the same thing for the libs list. So here we'll just add an extra space and then package config free type 2 exclude c exclude, come on now, C flags T. Okay. Let's try building that now and see if that makes a difference. Compilation buffer I want. Here we are. Seems to have worked that time, I think. Let's go back and just double check the build output. Field texture has an incompatible type, so let me go back into font.c. So anything Flux related. All right, so let's just do that. Anything capital Flux needs to be renamed. Let's see if that works. Font.o, still some kind of problem here. Texture has an incomplete type. Subst font. Oh, I need to include its own header, it seems. Font.h, there we go. Still didn't build, that's fine. We'll be done in just a second, I think. All right, still complaining about that. Implicit declaration of subst log. Okay, I need to put log.h in as well. I swear, every time I press that, it's annoying. All right, so for texture, font.c line 21, subst texture. Oh, is it something I did here that was wrong? I've changed how the types work here, so maybe this is sufficient now. Let's try that. Still no file or directory. Come on. Okay, so I just need to change some things here. Current char. And the texture needs to now be, we need to use, whoops, indirection to get to that. Now, what did I just do? All right, there we go. Texture dot. There we go. Let's fix the rest of these instances of that. Same thing here. Did I actually want to keep a struct reference in that? Let's go back into... Yeah, maybe I did. That could be a mistake. Let's do this. Let's just undo these things. And maybe leave it at that. What don't you like? Oh, let's just do this. So no pointer, just plain texture. Okay, this time it seems to be cool with it. We'll see how that goes. Okay, cool. It compiled this time. Implicit declaration of subs graphics draw texture ex. That ought to be in renderer.h. Draw texture. Okay, I took those out. I don't know why I took them out. Or now we're going to put them back because we need them. And we're going to change this to renderer. Ooh, good job. Renderer. Renderer. What do I call them in renderer.c? So texture ex. Okay, I call it renderer. So let's call context renderer in these cases. Renderer. Okay. That should be good enough. Just want to make sure I get these things not complaining about silly stuff. Okay, I think we're good now. Now that we got all that in, maybe we can finally get some text rendering on the screen. So I might need to go to Flux Compose and steal some of that as well. So let's go into font.c from the Flux Compose project, and then we'll go into, where was it? Graphics.c. Did I have some font code in here that I was using? Yeah, I think it was in here. So font just. And then, where do I want to do that? Maybe you need to make some indirections for this. Or some wrappers, let's say. So we'll need to add a module init function. Similarly to what we did in Flux Graphics, I think. So maybe... we didn't even do that. So things have evolved since we worked on Flux Compose last, and I think that we can clean up some of that code. So we'll go into font.c for Substratic, jump to the bottom, paste this, subst font module init, Substratic font, and then we can say, what would be font load? Let me check what we did in Flux Compose on that. So graphics.c, did we have any font functions in here? Font underscore, not there. Where would that be? Font load. There it is, font load internal, and then font load family weight size. Yeah, do I want to replicate that? We should probably just copy this code though. Let me go right here. No, not there. So, oh, what am I missing? Font underscore load underscore internal. Where is it? Maybe it's here? No. There we go. Okay. Different naming conventions. So let's copy this. Then we'll go into font.c from Substratic. We'll dump this in. Should have just copied the name too. Let's do this. Whoop. And then we're going to put it after this point. Okay. So now I think subst font star. Is that it? And this is going to be subst font load MSC. We'll just do it this way and then we'll change it later if we need to. All right, so this needs to be subst log Okay, now family, weight, size. We're printing the font spec. Anything here flux needs to be subst. All right. That should be okay. And now we'll go down here and delete all of that. Except for the last one. We need to keep the last one. All right. Now, subst, font load MSC. Okay, so that should be enough to load the font. We also need something to render the font. So if I were to paste this in, let's see, render font. And then this is going to be render font. I guess technically it should be font render. Whoops. But we already have some render texture nomenclature, so it seems a little bit backwards. I need to get my terminology together on all this and naming conventions. Hey, Bill. That's okay. And, you know, life gets busy and, you know, we can't always do the things we want to do. Sometimes we have to do the things we have to do, unfortunately. Nice to see you, though. Thanks for joining. Okay, so font load, render font. So we can probably steal some of the code that we had. Well, okay, let's just get it going. I'm going to copy this. Well, let's copy those things here. And previously, when we had been dealing with this, we were creating scene elements for text, I believe. So it's going to be inside of scene.c here. And I think there's text, render text. Flux font draw text. Okay. So we already have a function for drawing text. We just need a font, we need a string, and we need the position information. So that's what we'll be looking for: the font, the string, and position information. So this function will require 4 parameters. So first of all, we're going to have the font, which is as pointer args o, not 9, 0. And then the pointer inside of it, we're going to cast that to a not a flux font. Whoa, which file am I in? I'm in the wrong code right now. Lovely. Let's undo all these things I just changed. That's why it's a problem when I'm dealing with, you know, so many different code bases that I've been changing over time. I just end up causing problems for myself. All right, we're going to put this here. We're going to delete that. Render font, this will be called. Okay, now. We also need the string const char star text. Well, what does it take? Font load, font print all, font resolve path, font draw text. Okay, const char text. Fine. Sounds great. No, we're not going back to that file. Okay, so down here we're going to be. Was it right here? Okay. Text equals as C string args of 1. Float pos x equals as number args 2. I really need to do some type checking on these, but I'll do that another time whenever I add some helper functions for this. All right, so that should give us everything we need. And I'm going to return a tval. Because that's all we really need to return here. But I need to call the function for drawing. So subst font draw text. Oh, I need a renderer context as well. So I need to shift these parameters. So no, not context. I need a renderer. Then the font, which needs to be a pointer. Then the text. Then the pos x and pos y. All right, so let's delete all the crap off the end. We're going to copy this. We're going to change this to be a subst font. And then, oh, funny how I did that. Font, no, not font here. Whatever, font. Do it again. Subst renderer. It's going to be args 1. This will be, no, sorry, 0. 1, 2, 3, 4. That should be everything. Renderer, font, text, position X, position Y. Maybe it should be render text and not render font. Because you're not rendering the font, you're rendering the text using the font. So let's change that. We're going to call this render text. Subst font draw text probably should also be called render text. So maybe we'll change that as well. Check R count to 5. Thank you, IO Control, and nice to see you. All right, requires 5 parameters now. That would have been a problem. Okay, so let's change some function names just so we don't have a mess here. I want to change subst font draw text. Maybe eglot can help with this here. So if I say Control C R, no, that's not what I wanted to do. But at least it compiled. Control C, whatever. Eglot rename. How about that? So subst font render text. There we go. Let's see if it went in the header file too. Fonts, no, did it. Render text, there we go. Everything there should be good. Font, render text, font, render text, font, draw text. Okay, that got taken care of. Now we'll recompile. Something is not happy. I notice a warning. Incompatible type for argument 1. What don't you like? Render text. This needs to be a pointer. So let's go into the header and make sure that's also consistent, and it's not apparently. Fix this, renderer, okay. This also needs to be a star here because I'm changing the way that I was doing things before. I had a nasty little type def habit in the past. All right, so let's go back. What don't you like now? Conflicting types. Is it the return type is conflicting? Subst font render text. Line number 130 in font.c 130. 130. Hello. What's happening? 130 GG. There you go. Am I supposed to be returning something here? No. Subst renderer. Oh, there we go. That's the problem. And also, what am I calling this? Subst font. This needs to be font. Well, I've got a different naming convention for these now, but that's okay. We'll just put that there for now. Subst font render text MSC. Font render text. Not render. No, text. There we go. Okay. Something was slightly different that time, but it's still not completely happy. So let's give it a shot. Returning int from a function with return type subst font. Line number 68, -1. That's weird. Apparently I never saw these issues before. So we should return null, huh? And 98 has the same problem. -1, who knows why I was doing that? Null. Probably some old holdover code. And implicit declaration of graphics shader compile. I probably need to pull in shader.h in top of this file. And whoops, include shader.h. Then line 151, or somewhere nearby. Font is a pointer. Did you mean to use arrow? Where am I using font? That's wrong. Yeah, this function probably has a bad usage of font at some point. Well, it should be fine now. All right. Okay. Double check. Still, font as a pointer. Did you mean to use arrow? Did I have... Okay, let's go back to font. That's a problem. Right here. We don't want that. All right, and double check one more time just to make sure. Incompatible types. Oh, okay. So that also makes sense. I need to make this a pointer. Return a pointer. Okay. Then I need to go into font.c, font load, and then make this a pointer as well. Sorry for the delay on this. Not what I intended to spend my time on, but that usually happens. Okay. Invalid initializer. Okay, so I think 84, I need to make that be a pointer as well. Where are we? 80, come on. 84, GG. There we go, right here. That's important. And then we can do just that as well. Incompatible type for argument 1 of memset subst font. That's fine now. Okay, let's do this now. Probably should have converted this ahead of time, but I forgot. Context undeclared 157. That needs to be called renderer now, I think. So anything in this file called context probably is renderer. Yeah. Anything else, it's a total failure. Invalid initializer 242. This should be a star. 263. Probably the same issue. So that code would have been crashing left and right if we had started using it. Okay, this little block, I know what the issue is there. Flux log. That shouldn't be there. How many is that? Subst. Okay, just the one. Draw texture ex. Draw textures renderer. Oh, subst graphics. Any more of those? Wow. Let's just change all those. Subst graphics goes to subst renderer. I don't know why they're in there like that though. Func. Oh, that's like an internal function. Load internal. Ah, that just got copied in, didn't it? Okay, let's just delete that file, or that function. Render text, MSC, font load MSC. Okay, yeah, we definitely want to get rid of that one. Draw texture EX. Yeah. Hopefully that's the last thing. Okay. That looks much better. Now, let's go into main.msc and we'll try to call this stuff and see what happens. So I'll add the Substratic font import here, font. We'll also try to copy what we did in Flux Compose examples thumbnail, where we load the Jost font. I may need to change how that gets pulled in, but let's, well, I don't want Jost actually. I want something else. I want a bitmap style font. So I'm going to steal the one that I was using for the old crash stack. I don't know if I pulled that already. Let me check and see. Is that in my assets folder? Assets, images. Nope, I did not pull that yet. Crash the stack. Where's the Substratic one? Here we are. Okay, assets, fonts, Thintel. Let's download it. I'm gonna download it there, and then we'll go into Dired, assets, fonts. Then we're gonna go back to the downloads folder, Thintel. Where did it go? Thin. Who knows where it went? Where'd you download it? Probably won't show me, will it? Where is the target folder? Can you tell me that? Okay. That's strange. TTF? No. I wonder where it ended up. All right, let's do a save as on that. Because apparently it didn't put it where I wanted it to be. Save link as. Who knows, man? All right, home, downloads. Good enough. Now is it here? There it is, right there. Okay, so let's yank that. Go back into projects, code, crash stack, assets, fonts, and pull it in. There we go, thintel.ttf. That's what we want. Oh, you know what? I don't actually have something for loading a font file directly, so I'm gonna have to add that too. Let's see. What's that gonna look like? We're gonna have a different function that we'll need to register for that purpose. So we had font load. We're also gonna need font load file, I suppose. File underscore, and we'll need not family this time. We're gonna need path or font path, let's say. And I think I have another function for loading based on font path. So load file, font load file. So let's just go back here, font load file. I don't like how the stack jumping in evil mode is not working like it used to. Font load file. There we are, right here. And I'll call, see, font path, we'll just delete that, delete all these things until right here. Delete this as well, delete this. Okay, so now we can just move this down here. Join these lines up, delete that. So then subs to font load file, font path, int size. And weight, we're not worried about because that should be baked into the actual file itself. So this only takes 2 parameters, just the font path and the size. And that's the function we're calling. We're calling them the same, basically the C API version of the same function. All right, so now we're making the pointer for the font and then returning it. And that's subs to font load file. So we'll add font load file here. Load file. Okay, so now we'll go back to main.msc. We're gonna do a similar thing here as we did with texture load. Define bitmap font, who knows? Texture, no. Font load file, assets slash fonts slash thintel.ttf. And then the size, let's say 32. I don't know how big this needs to be, but we'll just use that for now. And let's run it and see if anything crashes. Okay, something did crash. So let's see what happened there. Undefined variable font load file. What did I do wrong with exporting the functions? This is in the right code. Font load file. Okay, Substratic font. Oh, you know what? I don't think I registered those functions. It's going to be in lib.c. We're going to go here. We're going to put font module init. We also need to pull in the font header as well. Font.h. Cool. Now, no such file directory. Undefined reference. Ooh. So we missed these the first time because apparently we weren't linking correctly. Let's think for a second. All right, let's see. Maybe I need some help on font config and, or is that, hold on. Oh, wait. Is that what it is, font config? Yes. Okay, so I need to pull in the libs for font config as well. So let me actually check that in vterm. So here we'll do, whoops, here we'll do, let's say font config. Great, that's all it seems to take. Let's pull in free type also. Interesting. Maybe I can just leave out the free type part of what I was doing before. I'll just pull in font config only. Let's see what that does. Hey, Crazy Chicken. Haven't seen you for a while. How's life in the Navy? You still there? Okay, let's see. I was going to go into the project.msc file, change this to font config. Font config. Hey, Jackson. And also free type to, let's change this to font, whoops, to font config. And let's see if this makes it happy. Go back to compilation buffer, build. Undefined reference to shader compile. All right, so that makes sense. Let's go into source shader compile. Okay, so there's no render on that function name. So font C. Let's kill these now because we don't need those anymore. They're going to get in the way. Font.h, take that one out too. Font.c. And shader compile. Okay, let's get rid of renderer here. Anything else shader related? Shader underscore? Nope. Awesome, glad to hear it. Okay. I think we're good. So Face Intel has 102 glyphs, so it did seem to load it correctly, which is great. Now let's try to draw something. Main.msc. Now that we can get font rendering working in this renderer, we'll be able to go and do the calculations for the text. Okay, so after everything else happens in the main loop, let's say render tiles, render swap buffers. Let's do this here. Render some text. So render text. Renderer, bitmap font, hello world, 0, 0. Let's just see what that does. I bet it's going to put things in the wrong place, but we're going to find out real fast about whether it does or not. Not seeing anything. Interesting. Let's see, render text. Let's see what the implementation has in there. Maybe I missed some things from the old implementation. Render text. Current char, draw args. Shader program equals 0. Font vertex fragment shader. Where is that? Font vertex. Okay, so that's fine. Shader program equals subshader compile. Then we get the text information. GL bind texture 2D 0. That looks wrong. Or is that after the fact? We're binding it after we just... Do we bind the right texture at all? That doesn't seem right. Curious. Seems like we should be binding the texture here before we try to draw anything. Unless... Yes, this function is taking care of it right here. So draw texture EX, renderer, current char texture. That seems right so far. Let me just write some crap out. So printf rendering text, just to see that it's actually happening before we go too far with our investigation. It's doing something. Okay, so it's in there. It's just not rendering anything visibly. A few possibilities. Is there not a color set so that it shows up, I wonder? We haven't set any text color. But then again, I don't think I actually support that yet. I don't think we support setting color on text. Because the shader does not take a color, as far as I remember. Fragment color is color times sampled. And where is color? Okay, so it's just straight up white color. Interesting. I haven't tried this font before, so maybe it's just something with this font. We may have to try another font just in case to verify. And if you don't like seeing all these memory leaks here, I've got a way to fix that. I just haven't done it yet. All right. So let's double check everything we did with the render text function. Renderer font text, then the position. Maybe we should double check what we're passing in. So print f text x, y. Let's just try this and see what happens. So text text pause x, pause y. I've got a bit of a cold this week, so it's messing with my head a little bit. All right, so hello world and then X and Y is 0, 0, like I expected. Let's move that position a little bit just in case for some reason it's causing unexpected things to happen. You know what? It actually is probably causing unexpected things to happen because we're not factoring in the height of the text. So if I were to go 50, that might help. There it is. Okay, so that font is really small. We're gonna have to jack up the size a bit. So I think 32 is what I said before. Let's say 320. That sounds insane, but on this particular computer, for some reason, the fonts need to be huge. And then back in font, let's take out that printf because we don't want spam the whole time. Wow, okay, too big, but not bad. We'll go back to main.msc. We're gonna change this to something more sensible like 200. How about that? Come on. Okay, so we're centering it. No, we're not centering it. We just haven't factored in the size on the position. Yeah, that's probably another thing we need to do is make sure that we're rendering text not at the baseline of the text necessarily, but at the top line of the text, because otherwise it's not going to show up where you expect it to half the time. Let's see, where was that going to be? Render text. Okay, so this probably should be, let's say, 200, just for experimentation's sake. All right, so now we got hello world. It starts at the leftmost side of the screen. What we want to do, which we finally got to now, is to make calculations that will put the text either at the center or at the right side of the screen, depending on where we want it to be. So let's do that. I'll write some code for that really quickly. First, let's add a little API function for that. So let's see. Font text width. We'll call it for now. Probably not the best name. That's good enough for me. Or string width or text width. Well, since we're calling it render text, let's call it font text width for now. And we'll make a little function to do the calculation for that. So I can copy this little bit here. Probably also want to copy these two things. So we want to have the font. We want to have the text string that we're doing the calculation for. We're also going to return a result. So we're going to return a number val. And we're going to call into an API function for that. So subst font render text. No, subst font text width. And that's going to take in a subst font. So just the font and the text, right? All right, so now we're just going to write the function right here for the sake of making it work fast. Subst font text width. Subst font pointer font. And then const char star text. And then what we need to do is a similar thing to what we do in the rendering function. Where is it? Right about here. So I'm going to copy this little bit to this point in time. Daigo says, how about showing the to-do currently being worked on in streaming, for example, in an empty space in the polybar? That's a great idea. It's something I want to add soon whenever I have a little bit more control over what's happening on the screen, like, you know, be able to set it easily. I mean, I guess I could set up a little overlay for that, but I just haven't done it yet. But great point. Thank you, Daigo, for the suggestion. All right, so what I'm going to do is copy a similar approach here. Let me just copy all this code and then delete the things I don't need. So I will, where did that little function go? Down here. All right, I'm gonna paste this in. X and Y, we can take the Y out. We might need the I. I don't know about the num chars. We probably need that. We don't need to draw args. We don't need to set up the shader. Num chars we will use. I think we can just move that to here instead. Just initialize it directly. Get the character information. We do not need the Y position information. We don't need to draw the texture. So X equals position X plus current char bearing. So where do we use X again? Position X. There's X in position X. That's really confusing. Where does position X even show up? Let's go look. Ah, the original position we passed in. So, okay, that's sort of just keeping a record of where we've been. But X and Y ought to do that too, it seems. Maybe I need to simplify the algorithm a little bit. Okay, so here, X equals position X. So let's just say X equals, or plus equals. And then we'll do this also. So I suppose we could just add it all together in one step. Do I need to break out at any point? No. All right, we want to put it in the right place with the bearing and then add the advance after we draw it so we have the right spacing between the text, it seems. But I'll just do it this way because I think it's going to be simpler and will save us some extra calculations we don't need. And this plus equals, I don't know what that turns into in the end, but we'll go with this. Let's make sure that we are grouping this correctly also. All right, and that should be good enough. And we're going to clear this thing here. Return X. So that it should return the final width. In fact, let's say width here instead. And then we're going to call this width. We're going to call this width also. We may not want to have that advance added at the very end, so I might have to skip that for the very last index. But we'll deal with that in a second once we see what the results look like. So this should give us the text width for a given string. And once we have that, we should be able to offset the rendering of the string when we call the function to put it wherever we want. So let's go. Let's see. Let's make sure we're actually returning the values correctly here. Font text width, font text width, font text width, font pointer args0, args1. Let's put a little guard in also to make sure they pass in the right amount of arguments right here. And then, yeah, okay. That seems good. So now we'll go into main.msc. I can define something for this. Actually, well, okay. Hello world width is font text width of bitmap font and hello world. So I'm just doing this very, very basically at the moment. That should give us a value for that. And now for the X position, what we're going to do, I think we have a screen width somewhere. Window width. Okay, so window width. Let's take this whole little expression there. So we're going to, whoops, we're going to go down again to this part of the code. And then we're going to paste that in. We're going to say the window width divided by 2. Then we're going to subtract from that the hello world width divided by 2. Hello world width. All right, so that should do the trick for that calculation. Yep. Now let's take the 0 out, clean this up a little bit, and hopefully we'll see this render the text centered on the screen with respect to the width of the window. All right, so we got a little crash here. Let's see what happened. A lot of spam. Font text width. Font text width. Something did not happen. All right, we got a little error here. So font text width is undeclared. I don't think so. Font text width. I missed something. I think I did a mistake right here. So font text width. I just copied and pasted the function signature, did not update the name. Let's try this now. Still got a crash. Operands must be numbers. What did I do wrong? Maybe we should start off by printing out what the width is. So display hello world width display hello world width, and then display a new line. This is really ugly. We need a format function, but I keep saying that. 565. I mean, that sounds possible based on the size of the font that I am drawing there. So operands must be numbers. What did I do wrong here? Window width, window divided by 2. Oh, okay. That needs to be there. Fine. This should do it now. Okay, hello world is now centered, and if I expand the size of the window, then that does remain centered. That's great. So that is validation of that part. What about if we want to right align the text, which is ultimately what we want to do with an FPS counter? So I could even say here, render the FPS, and then instead of doing the window width divided by 2, I'm actually going to say I want to subtract from the window width the hello world width. Just period. Like I don't want to divide them by 2 because I don't want to center it at all. I just want it to show up. Effectively, the width of the entire string just moved over from the window width itself. So that should right align it. Okay, that looks good. And then if we maximize the window, it still looks good. If we wanted to, we could also add a little bit of padding so that it doesn't stick to the side so much. So I can subtract, let's say, another 100 pixels from that. That's a little bit too much. Maybe we'll go with like a 25. And now that looks good. I'll leave it like that. So I'm going to scale that font down. So instead of it being 200, let's try 100, see what it looks like. Okay, that's still a little bit big for my purposes. Let's go with 75. All right, that's more like it. So I like that size. What I'll do is go back down here. I'm going to change the Y position to something more like 50, let's say, to make it sit more in the upper right-hand corner. Okay, so that is more like what I'd like to see. Also, this one, I can make this 50 also to give it a little bit more of a clean offset on both axes. No, that actually is worse. How did I do that wrong? All right, so maybe let's go with a 75 on the Y on this, and then that still needs to be 25. Okay, that's a bit better. Let's move this back down to 50, let's say. Is that what we had before? And I didn't notice that it looked right to begin with. Yeah, I'll bump it a little bit, but that's fine. Okay, so that gives us the starting point for having an FPS counter that we can just sort of track what the frames per second readout is at any given point. What am I doing? I'm always doing the wrong thing here. This needs to be 60, let's say. Okay, that's perfect. I like that better. Cool. So now what we can do is display. Oh, no. We're going to do. Crap. I haven't actually done this yet. Turning a number into a string. I may need to make a function for that, which is not a problem. First of all, we're just going to say FPS colon. How about that? And then we'll add the FPS in after. Why is it so far off? Something with my calculation is wrong. Hello world width is 207. That seems possible, but perhaps too much. All right, so I wonder if this extra subtraction is doing something weird. I can't add or include multiple values here yet. I haven't actually added support for that in the language. So we're having to do this sort of nested subtraction. Whatever, we'll go with it for now and we'll adjust later if necessary. So, FPS. So how to calculate frames per second in game engine. Now there's a way to do this like smoothly so that it doesn't jump around so much. Yeah, I think this is something like what I was using before. You need a smoothed average. The easiest way is to take the current FPS and then combine it with the previous FPS. This is doing some kind of like window move. That's fine. That is not right. Increment a counter every time you render a screen, then clear that counter for some interval. All right, so I think we're gonna stick with the simpler approach here. We're just doing like a rolling average, which is fine. Measurement times smoothing plus current 1 minus smoothing. Yeah, that seems more or less right. It's not accurate, super accurate, but it's enough that it will stabilize. All right. So, time to render the current frame. So let's define game loop. This is a function. We can use a let inside of it for that, or we can just store a, well, okay, so storing a global is actually going to be slower than using a local variable, so maybe we do actually need a local scope for this. So let, it's almost like we need to have a full named let inside this function, so we can just call game loop and let the real inner loop run. Because game loop itself doesn't actually take any inputs. So here we could do that. We could say frame time. Now what about the previous frame? Current. Let's just call it 0 to start with. How about that? All right, so frame time is 0. And then we're going to move everything inside of that. Next frame is going to be inner loop. Or, oh, just call it next frame. How about that? Next frame. And then we need to calculate the new frame time here. So here we'll call this next frame, right? Okay, now we need a starting time that we can set. Might be nice to have a variable for that. We could say start time is, well, we also need a function to grab what the current time in milliseconds is, I think. Let's see. C get current time in milliseconds. Time in milliseconds in C. As you can see, we find Stack Overflow quite often. Microsecond resolution. Get time of day. Get time of day together with time difference millisecond. I don't really need that. Oh, okay, they wrote a function for that. So TV sec times 1000 times TV usec divided by 1000. Timestamp in milliseconds. Okay, so one of these things is probably what I want. I mean, nanoseconds could be useful for games, I suppose, but I don't know that I need to go that far. So let's see about something like this, which is similar to what we saw before, I think. Yeah. Okay, so get time of day. Where would I put that? Which library would I put that in? I mean, we could have a time library, I suppose. That requires adding another library to mesh, which is not my favorite thing to do, but probably the right thing to do in the short term. Or I guess in the long term, right? Okay. let's do that. We're gonna go into deps, meshlang, compiler, source, time.c. Probably need a time.h. Let's go steal, let's say array.h. Let's steal the header for that. Then use an end if. Now the only thing we need here really is the module init function. So we're gonna copy this. We're gonna say time here. We're also gonna say time here as well. And then we're going to include vm.h. So then inside of time.c, we can paste the function definition for that. And then let's go to, I don't know, let's say array.c. Go down to the module init function, just copy that shamelessly. Excuse me. And we're going to change this to time. We're going to change this to time. And then we are going to delete all these and then turn this into time current millis or imsec. I don't know. It's not the best function name. Time current imsec, but it's what I need most often. So at least for game development, probably also for music and video too, but we'll get more into that later. Let's pull in, include, what is it, time.h. Also need include, well, we don't need VM because VM is already in there. But we do need to have a function for time current imsec. So let's go into array, just grab the declaration for one of these bad boys and then paste it in. All right. Now we want to have time current imsec. This is going to require no parameters. Accepts no parameters because we're really just getting the current time. So we're going to be very plain about this. Okay, so let's go back here. We're going to pull in this stuff. I'm just going to change it a bit though, because obviously we don't want the Stack Overflow police coming to arrest me. Pull in this systime.h. Probably need to put it above here. That's all good. Now, what do you not like here? I need to wrap this inside of a number val. Okay, and then what's this plus unhappy about? Invalid operands to binary expression. I think I must have wrapped this incorrectly. So let's wrap everything. I don't like that long either. It doesn't look right. Uh-oh. My lights are falling. Okay. So, that should be good. Maybe that will give us what we want. Still need to go into vm.h. Whoops. vm.h. No, vm.c. Module init. We're going to copy one of these lines. We're going to say this is going to be the time module init. And I'm going to go up to the top. And then put in time.h as well. Now I should be able to go into main.msc. We're going to say mesh time. And then here we're going to display what the time is. We still need a way to convert a number to a string. So I guess I need to add a function for that too. So how about I go back into string.c. And we'll say float to string. Or maybe it needs to be number to string because we don't really think in terms of floats right now. So number to string. So string number to string. All right, so then I'll just copy this here and then drop a little curly brace. Get rid of that. String number to string. Now what we need here, we also need to throw an error, but let's do this. I don't know why I had it set up that way. That's a really weird way to set the function. It needs to panic. Whatever. We want to do, what is it, like I to A, C, but it needs to be like the float version. I'm just going to try to find this first, and then we'll find the right one. Hey, Fade. All right, so value, char, string, int, base. So you pass it your own string. You have to have a buffer. Okay, that's fine. We'll just dupe it. No big deal. Or in fact, I think it's already happening. Yeah, all right, that's cool. So we will have a char buffer. Let's just make it be, I don't know, how many numbers can you actually have in a float? Buffer of 512 bytes. That seems a little excessive, but 256. Is that enough? And then is it F to A? So F to A. Yeah, okay. So that's probably in standard lib, I guess. Do we have that? Yeah, we got that. And then if I go back to the I to A that I was looking at before, then we need the value, the string, and at least for integers, the base. But F to A probably has its own signature. So let's look at this. F to A after point should store 1.55 in res. Okay, I like that. So that's the way we can say what the decimal limit is. I'm just going to say 3 there for now. I'm going to hard code it to 3, then we'll make it a parameter later. So F to A args 0. This needs to be as number. And then the second parameter is going to be that buffer. And then the next one's going to be the... Oh, get out of here. I love this. Just whenever I was actually getting value out of the site. Maybe I could jump back there for a second. I don't know. Come on now. Show me, show me, show me. After point. Okay, so it's just a digit or a number. I'll put 3 here. All right, so that's good enough. And then I can return as... No. Object val, mesh, object, make, string, VM star, mem. Need to clean that part up for sure. Then buffer, and then string length of buffer. And, whoop. And we don't really care about what happens with this buffer because object make string is going to copy to its own allocated string information. Implicit declaration of F to A. F to A standard lib. Is that where it's supposed to be? Convert a floating point number to string in C. Tell me the header, please. Math. Potentially. No, you're making your own? I don't need that. Okay. Maybe this doesn't exist. It must exist though, shouldn't it? I to A. Let's see. glibc F to A. Is that real? Isn't a part of libc. That's something else. ABR libc. Float to string. Okay, so C convert float to string. I mean, one thing I may have to use is like sprintf, float to string, which is not the worst thing in the world. GCVT. Where is this from? Okay. That seems to be exactly what we were using before. Is the things are in a different order. GCVT. Ah, come on. C, standard lib. Convert double to string. Okay, that's fine. Double float, whatever. Get out of my face, man. GDPR, I hate it. Double floating point argument values to floating point output strings. Standard lib. Okay. What is the FCVT? GCVT, FCVT? Oh, okay, it's like a format thing. Whatever. So GCVT, is that it? GCVT. There we are. Double value digit char buffer. Okay, so we just got to roll these around a little bit. We want that one still. Buffer just needs to go at the end. Okay, so that should do the trick, and let's get rid of that one. String number to string. Yes, the duplication is intended. So now, back in main.msc, we could potentially write this out every frame just to see what the current time in milliseconds is. Let's see. Start time is going to be time current millis. Let's go with that. And also in here, we can say, we're just going to do this for temporary purposes. Display current time. In fact, now we can use string append. Let's see if this actually works. And then number to string. Start time. No, not start time. Let's call it again. Time current millis. All right, so that should do it if it doesn't crash. Undefined reference to mesh time module init. That is happening in vm.c. I've pulled in time.h. What did I do wrong in time.h? Okay. Time module init. Time module init. Oh, I think I forgot to add time to project.msc array. So let's go add time.c right there. Okay. Then compile again. Undefined reference to panic. Time.c. Let's go put util.h up here also. I believe that's where it's at. Util.h. Arrow at. Oh, wow. So can I not actually put that in a symbol name? Huh. Let's see. The scanner needs to be updated to take arrows inside of function names or symbol names. Let me think about that for a second. So if I go into VM, jump over to scanner.c, symbol. Let's see. Where is all the characters at? Okay, scanner read identifier. This needs to be added. So I'm going to add an extra one for the arrow. There's other characters that could probably fit in this as well, but we're just going to go with this for now. Yes, kill it. All right, what just happened? Yes. What the hell, man? Okay. Something crashed. Let's get up here and find out. Come on. All right, hello world with PNG load. All right, so it crashed without actually triggering address sanitizer, I think, because it's just looking at memory leaks at the moment. So if I were to run that in GDB, args .tools. Now we want to go to bin/dev/crash the stack. Yeah, okay, fine. Need to fix the manifest path. Okay, let's run it. Fatal error. What? So we didn't even get a backtrace. How did I screw that up? All right, so maybe it's to call into the time function somehow. It could be either that or the string conversion. So let's go back to main. Take that out first, just to rule that out as a possibility. Okay, so definitely it's probably calling current time current millis. Let's put a 0 here and comment that out and see if that solves the problem. Curious. What did I do? What is new? Next frame, I did not pass in the proper parameters. So let's put in start time and frame time. Just pass them along for now because we need to fix that in a moment. Start time, frame time. Okay, so that solved that issue. Now let's go back and put this back in and see if that is happy. That's not happy. Undefined variable time current millis in time.c, time current msec. That's the reason why. Msec. Millis. Msec. All right. Let's try that now. Seems good. Now let's go do the printing operation. All right, so that's not happy. Undefined variable string append? Really? Huh, never had string in here. Interesting. Mesh string. Guess I didn't need it before. All right, okay. So we're getting some current time out, but it's giving us like significant positions or something. Let's see. New line on that. All right, so that doesn't look like what I expected to see. But that's probably right. 6e plus 12. Does it ever change? Or is it always the same value? Hard to tell. Let's see. Convert double to string. Double floating point arguments to floating point output strings extended to determine the floating point format. Number of digits. So I think the number of digits is probably the problem. But I kind of want to trim off that stuff at the end. So maybe one of these other ones that I saw is the correct one for that purpose. So what was it? ECVT. There was another one too. C. Or standard lib. There we go. Double value to a string and returns a pointer to it. Integer pointer which stores a decimal point position with respect to the beginning of the string. Okay, that's a little bit more advanced and I don't need it. What else did I see? There was another one. Was it FCVT? Number of digits desired after the radix point, the decimal point, and returns a pointer to the string. The total number of digits in the result string is restricted to an unspecified limit. Okay, maybe the right approach to this is using sprintf instead. So sprintf float 3 decimal places. Okay. F is floating point number. Precision specifies the exact number of digits to appear after the decimal point character. The default precision is 6. Okay, so maybe it's what I'll do instead. Sprintf, you have to have a buffer already. which is fine. We have that. All right, so let's go into, what was it, string.c, and change this to not use GCVT. Instead, use sprintf. We're going to print that into buffer, and then we're going to use .3f, I think. We are not going to put a new line. And then we're going to pass in, oops, yeah, we're going to pass in this parameter here. This should give us the more optimal output, I think. Let's try that. Okay, so yeah, cool. That does seem right. We are getting increasing numbers there. So probably that is the milliseconds since the start. So now we can use that in our main.msc function to get how much time it took in the current frame. So let's say last frame time is time current milliseconds. We're just going to say the last time was now. And then frame time, well, let's just leave that one for now. Here, when we call ourself again, for last frame time, we're going to say time current msec. Frame time, well, I guess we kind of need to call it more than once, but whatever. We'll deal with that. Kind of want to set the value. Last frame time. We know what the current frame time is by saying frame or time current sec minus last frame time. That will give us the amount of time spent in this frame for everything that happened. And then if we go back to that example we had for getting the FPS, where was that now? So if what we want is to divide by 1,000. Is that right? Frames per second. Yeah. So the amount of time it took in the current frame. You know, I have some code for this in my other project. Let me just go check that because I don't want to spend too much time here. We're almost at the end of the stream, and I think we're getting close to having this working. So let's take a look at that. It could be in the old Substratic library, so I'm going to have to look there instead. Okay, let's go look at that. I think it's going to be in the old Substratic engine. And what do I... Okay, engine 4 Gambit, that's what I was calling. Let's see, not components. This is going to be in renderer, I think. FPS, no. Was there an FPS file? I think I may have had one called FPS at some point. All right, let's just search for FPS. Whoops, that's not the right thing. FPS. All right, this is the FPS component, interesting. FPS updater. All right, so frames per second is let's see, if frames per second, so with the previous frame per second, we are smoothing that into 1 divided by the time step. So time step is something that I have forgotten about, but I think it's what we do want here. So let's go look at that too. Was it loop? Time step. Okay, so current frame time minus last frame time divided by 1,000. So let's calculate that. We do need that. And for time step, is that something that was like a local variable? Next frame. Last frame. Okay, we have it being defined inside of next frame. And it doesn't get passed into the following frame. So we only have the current frame time in my old implementation of next frame because I had a very similar thing going on here. So then what we could do is say another let, and then time step is going to be, all right. current frame time minus last frame time. Okay. And yep, that seems correct. So let's do this. Okay. Put this on around everything. Now we have time step, which is currently set. And that's going to be the time step for the entire frame. So we're basically saying that since the last frame, whatever that was, this is the amount of time that happened since then. So that gives us our sort of multiplier for activities that need to happen in the current frame. Now what I was doing with the frames per second calculation is that I was saying 1.0 divided by time step seems to be flipping that value and then smoothing it into the frames per second. So we were maintaining a previous frames per second. So maybe what I'll have here is FPS. And if it's nil to start with, which it will be, then we will see frames per second, if frames per second. If it's not, then we say, okay, we just look at the time step. So we can just sort of copy what I was doing here. And this will happen probably toward the end after swap buffers. All right, so I'll update this. Whoops, I think I need to add another paren at the end there to balance this all out. Okay. So if FPS, which means if the value is set, which at first it won't be, then if time step is greater than 0, then we flip time step. That's the current frames per second, and we put nil here. And then we will take the current FPS value and then smooth that with the current time step. All right, so now we should be able to, well, we need to do the rendering of the FPS. That's interesting. Whatever, we'll just leave it as is for now. String append FPS is going to be number to string. We need FPS to be something. Okay, so how about this? If FPS, then we're going to render the FPS string. So we're appending FPS and the number for the FPS to string. And we're also calculating it here, but we need to set that into FPS, the local FPS variable. Okay, so calculate the FPS. Let's see what that does now. And what about current time? Let's comment that out for now. All right, we got a little crash. Who knows why? Current frame time. Current frame time. Current frame time. Okay, time step. Where's current frame time being set in this file? Interesting. Current frame time. Time current imsec. This could have horrible results at first, but that's fine. And last frame time, current frame time. I'm trying to like think of the rationale here. So whatever was current is now going to be previous. So current frame time, and then the new current is going to be the current time. And then we're going to pass in the FPS value as well, which is going to be FPS. That looks good. Another crash. Time current imsec. Imsec. There we go. Infinite. Well, that's fun. Let's print out the actual value. I mean, I guess infinite is what it's going to show me, right? Let's see. If FPS plus 0.5 divided by time step. So first of all, display string append time step. And we're going to put number to string time step. Just to see what that writes out. Whoops. Okay, so we got some decent looking values there, I think. Let's take a look at that with a new line interjected. Okay, so that looks right. That seems pretty reasonable. So now for FPS, if FPS, the if has the if case and the non case. All right, okay. If time step is greater than 0, then use 1 divided by time step, otherwise return nil. So we should hit this at the very beginning because time step should be nil to start with. No, it's not nil to start with. No, that's right, sorry. FPS is nil to start with. I guess we could just push this over here too, right? Let's just do this. We don't need to do the whole set operation there. We can just drop it right here. I probably had a reason for doing it the way that I did, but I'm gonna just update this. And see if we get a different result. Okay, it still says infinite. Time steps being updated correctly. We can say also what the FPS is here. So let's do this FPS. We're just gonna write it out and see if it gives us a different number. Because maybe I'm doing something wrong in the calculation. FPS, run it. Okay, so FPS seems to be a real number, but for some reason the function for drawing text is not updating it correctly. Which is kind of interesting. I mean, so far it seems like we have, you know, pretty decent frames per second, if that is in fact the right calculation. Just curious as to why. Maybe I'm putting something in wrong in the no, number to string is actually doing the right thing because we saw it printed out. All right, so let's do something different here. If FPS is nil, let's just render another string foo. Just to see what happens. Oh, it started doing something and then it stopped. It started rendering. I saw it for a second. Huh. It hits it really fast, apparently. Where was the FPS print? All right, let's put that back in. I want to see if it hits infinity on its own. Oh. All right, something about my calculation is off. I think it just keeps going and going and going until it hits infinity somehow. Time step, current frame time. Divided by last frame time, yeah. No, minus last frame time divided by 1,000. That's our time step. And then inside this function, the actual calculation of FPS, frames per second. This all seems right, I think. Maybe something I'm doing is wrong in the calculation somewhere. Okay, well, we didn't get to the actual screen scaling stuff. I may do that on my own time. We'll see. Maybe we'll do it on Thursday just to sort of finish off the preparations for Ludum Dare. We did get pretty close for the FPS. I might just try to fix that myself off stream, but I'm pretty happy with the fact that we've got, you know, text rendering working again in the engine. We did get text alignment working. I mean, we're calculating the FPS. It's just not working correctly. So we say something about that. Render some text. Render the FPS counter to the top right. We did get that working. I mean, rendering text elsewhere, that would be easy if we wanted to do that. In fact, we could do... Is that an array? Yeah. Okay, so we can say how many tiles are left. How about we do that really quickly just to see how that goes. All right, so I'm going to say... yeah, this is going to be interesting to see the performance impact of some of these things. So tile count string is string format, string append, tiles remaining. And then we're going to say number to string. It would be nice if it didn't use a decimal place, but it probably will. I don't really care right now. Array length tiles. Is that right? Okay. And then we're going to say render text, renderer, bitmap, font, tile count string. We'll use the same Y position. Or no, let's do this. Window height minus 60. That should be a decent starting point. And then we're going to use a similar thing where we say window width of window. Oh, I need to fix this too. Window width of window divided by 2. And then we're going to count. Let's see, what was it? Font text width for the bitmap font and the tile count string. I'm going to divide that by 2. We're going to center this basically. It would be nice to have a function that does this for us, but we don't have that for now. All right, so that should take care of rendering this stuff. And let's see if it actually works. Compilation. Premature end of expression. I did something wrong. Ah, this one right there. Yes, kill it. Okay, tiles remaining 20. So that did work. And the FPS is is doing something until it doesn't. Okay, that's fine. So it'll be nice to remove the decimal points, but at least we do see that we're doing tiles remaining here. We're rendering it in the center of the screen, at the bottom of the screen, consistently, and whenever we start removing tiles, it will tell us how many tiles are remaining. So that's good. I think we made a good progress on that. Okay, so let's call that working, and we can check that one off the list as well. So let's go back to this one here, render some text elsewhere on the screen. So yeah, really all we need to do is just fix the FPS counter, and then we can write the viewport size calculation. In the next stream, we might go back to trying to do the finishing the cleanup on the CI for auto-publishing builds of the game, so that then on Saturday we'll be ready, or Friday to Saturday we'll be ready to go as far as writing all that code is concerned and getting builds pushed out. So I don't know, I'm fairly happy with the results of the stream today. Not a perfect stream, but pretty good. So we will see you back here next Thursday to finish up some more stuff and get ready for Ludum Dare on the weekend. I will be streaming some of that effort, but some of it I may be doing, like talking about it on Twitter. So follow the Flux Harmonic Twitter account, twitter.com/FluxHarmonic, and then you'll be covered in both places. So anyway, thanks a lot, folks, for joining today. I really appreciate it. And until next time, keep it creative. We'll see ya.